Hello everyone, welcome back. We're talking again about Stata, and this time we're going to talk about panel data using Stata. As we mentioned in the other class, the easiest way to get data into Stata is to import from an Excel spreadsheet, which I'm doing here, as you can see, Excel spreadsheet. And then you browse. I prepared a file for this class, which is countries data. Then I'm going to select this worksheet here and click this option, import first row as variable names. Okay, and that's it. If you click here, you'll see the data plotted here. 6 countries for each country from 2008 to 2020, those 5 variables, which are explained here, as you can see. I got this data from the World Bank database, which I'm going to show at the end of this module, how to get data there and some other sources. But that's it. The data is okay. It seems to be working and it's fine. So the first thing we need to do is to define for Stata that our data is a panel type of data. So the ID will be ID. I got this column called ID, which I defined for each country one number, which is the ID. And time variables you can use if you want, but not necessarily. In this case, I'm going to use year because I had the year. And okay, so it recognizes my data set from 2008 to 2020. So 8 columns and 78 observations. We're not going to use all of them. So let's go. First thing is to check if those variables are stationary or not, because if they're not, we have to use first difference, right? And I'm going to go again for you to see the way. Statistics, longitudinal panel data, unit root tests. Those are the tests that we use to define if a series is stationary or not. They bring here several options. I'm going to stick with the first one because in general, they tend to bring similar results. If you run them all, they tend to bring similar results. And I'm going to do it for each variable. So exports here. Let's run, see how it goes. So this output, you have the p-value here is smaller than 0.05 if we consider a 95% confidence interval. And because it's smaller, we reject the null hypothesis that says that the panel contains unit roots, which would mean that it would be non-stationary. So as a result, we consider that this series, exports of goods and services, is stationary, which is good. It means that we can use it. And then you have to do the same procedure with all the series that you're going to use here. I'm not going to do it all of them here because I believe you get the idea. You just go unit root, choose the different GDP growth, for example, click 0, 0, 0, 0, so we reject, so it is stationary, and so on. You do it for all of them. When you're working with your own series, you have to check them all. If it's not stationary, you do the first difference and work with the first difference. Okay, so considering that they are all stationary, let's go to the next step, which would be to build the models. Let's stick with fixed effects and random effects. As you can see, Stata is really easy to use. It brings pretty much all the information that you need. Dependent variable. I'm gonna build my model here, thinking that GDP growth, and when you're doing it yourself, you have to have some arguments to build this equation, right? You have to define which variable is the dependent variable, which variables are independent, and why. You have to explain why you're choosing those variables, apart from doing the math, to provide some sort of rationale, not just say that you're inventing or coming up with series that bring a good result without having any logic. So that's an important part of your research, is to find a good reason, a good explanation as to why you were choosing those variables. So let's suppose that I want to predict GDP growth. Let's suppose that I work for the government and I want to know what other variables, what the country must do to make the GDP grow. And then I'm going to put GDP growth as a dependent variable. And then the independent variables will be exports of goods and services, imports of goods and services, inflation consumer index, and revenues excluding grants. Okay, those are the other 4 variables I had in the model. And then I'm going to run GLS random effects. And it comes up with this table of results and coefficients. And as we can see straight away that which ones are important, those 2 are significant, the other ones are not. So revenues excluding grants is relevant, and exports of goods and services is also relevant. And I'm going to type a command here that I suggest you to take note. I'm going to type estimate store random, which is basically storing this value here because we're going to use it for our next analysis. And then I'm going to do it again. Statistics, longitudinal, linear models, linear regression, which the variables are already defined. And I'm going to choose fixed effects. Click OK. And then I'm going to type estimate store, as I did fixed here. I'm going to store fixed. And then it is stored. And then I have to run the Hausmann test to check which of the models are more appropriate. And the test that we do to decide if we choose fixed effects or random effects is the Hausmann test. In this case, I'm going to type Hausmann random fixed. Most of the times you can use those menus here, which I recommend you to do because they bring the command with no mistakes. It's easier, don't make mistakes if you use those menus here. But this for the Hausmann random fixed, the Hausmann test, I'm using the command here. And then it comes up with this result. So this is the output. If you're not really, if you don't feel really comfortable with it, I suggest you to do the same thing. Copy it. Just go to Gemini and then interpret and see what it says. So it says that the output shows that the Hausmann test has failed. The results are invalid. And you cannot use this output to choose between fixed effects and random effects. And there's the warning here. And then the way you have to solve it is to use this sigma more option. It also says what we have to type in the command line, which is great. So I'm just going to copy here the command line, type it, and then it comes up with a different result. Let's see the interpretation of this result here. And the result says that the Hausmann test also failed, even using the sigma more option. In this case, this is what happens in real life. Unfortunately, those things happen in real life. If you have an inconsistent test, you might present both if the results are too different. Let's take a look. Again, at the coefficients, right? So random effects, they had that exports of goods and services is the important one with a coefficient of 0.60 something. And the revenue excluding grants is also relevant with the coefficient of 0.44. With the random effects, we had the exports of goods and services also relevant with the coefficient of 0.62 and the revenues excluding grants with the revenue of 0.25. So the coefficient for both random effects and fixed effects for this variable is very similar. So we can consider the exports of goods and services is an important part of defining the GDP growth, the annual data for GDP growth. Revenues excluding is relevant, but the coefficient here is 0.25, and here's 0.44. As the Hausmann test doesn't define exactly which models should we use, I believe you should present both. If you're presenting it in a paper, you just put them as an appendix for you to show that you did it. There are other interesting things we can get from this result. Let's suppose that we decide that fixed effects is the most appropriate model. for our regression. The R squared overall and between and within is 65, which represents those numbers are good. We probably take a look at within. So 65% of the GDP growth would be represented by the exports of goods and services. Of course, that is not totally true, but that's what the numbers are saying. And in reality, we have to take a look as if the numbers that we got make sense in real life. So GDP is not 65% of GDP is not defined by exports of goods, but it represents that exports of goods is something that is positively related to GDP. So if we export more, we tend to have a larger GDP, which makes sense. And some other important thing is this rho coefficient here, which is 0.91, is really high, representing that the variance occurs between countries, not within countries. And that also favors us using the fixed effects model for this analysis. Yeah, sorry to say, but in real life, you are going to find data that is not very appropriate for your hypothesis. And finding a negative result is also a result, is also something important to publish sometimes. And I strongly recommend you to check on AI models, your results, to see if the interpretation that they have here is what you want. The interpretation that they bring is very good. I've found some mistakes, but the overall idea, even the text for interpreting the results, the coefficients, tend to be really good. And that's something that you can use in your favor. So this is our panel analysis here using Stata. Of course, the software does a lot more. There are hundreds of other methodologies that you can use for many other purposes, but those are the basic ones that you need to learn to present an article or a paper. If you do this that I showed you, it's already good enough for you to post the first draft, the first version of your article, unless you're trying to do hardcore econometrics or economics. If you're just working with regular data, this should be enough for you to present it in a conference or to publish an article on not very complicated data. Okay, that's it. Thank you.